Problem 4. I need to find out the value of this load resistance to get maximum power at load. Also I need to calculate value of maximum power at load. I am following maximum power transfer theorem. First I need to find out BTH or open circuit voltage. This is the main circuit. To simplify the main circuit, at left side of this AB, that is this portion, I am using Thevenin to use it with single voltage source and a resistance. So while I will use the Thevenin of this portion only, there is a current source, this is one resistance, and if I use the Thevenin, what will be Thevenin voltage? This Thevenin voltage is potential across this resistance, so that will be current multiplied by this. What is the value of the current? Current is 2 ampere, so that 2 ampere multiplied by 10, that will be 20 voltage. So BTH is 20 voltage. See here. What is the RTH? For RTH, I shall open this current source. So here RTH is just 10 ohm. See, this is 10 ohm. So this is simplified circuit. To find out BTH, I need to open this one. So I have opened this one. Now the open circuit voltage here is actual BTH. What I did, I just converted this circuit into a voltage source and resistance. The rest part are same. So what is the open circuit voltage here? This open circuit voltage is voltage across this 2 ohm resistance plus this 10 volt. If I consider this is positive, this is negative, then positive, negative, positive, negative. So this VOC will be voltage across this plus 10 volt. So this one. Now what is voltage across this resistance? Voltage across this resistance is this current I multiplied by this 2 ohm. Now what is this I? I is equal to total voltage in this circuit divided by total resistance. Now see here, minus plus plus minus. If I consider this voltage as positive, this will be negative. So ultimate, the equivalent voltage of this loop is 20 minus 6. So 20 minus 6 is the voltage, and resistance is 10 plus 5 plus 2, that is the circuit resistance. So this portion is the current, that multiplied by this 2 ohm, ultimately I got 28 by 17, that is potential drop across this 2 ohm resistance. So that will be added with this 10 to get this VOC. So ultimately this VOC is 10 plus 28 by 17, I got 11.65 volt. This is VOC or Thevenin voltage. Now to find out Thevenin resistance, I need to open this load resistance. Here I have opened, and current source will be open. This current source is open. This voltage source is shorted. Voltage source is shorted. So ultimately I got this. From here it is clear that 10 plus 5, that is 15, is in parallel with 2. 15 in parallel with 2. Ultimate I got 1.76 ohm is RTH. So this is the equivalent Thevenin circuit. RTH is 1.76, BTH is 11.65. To get the maximum power at load, according to maximum power transfer theorem, load resistance should be equal to Thevenin resistance, that is 1.76. And using the formula to get maximum power, I got maximum power at load is 19.2 watt. Now checking it in simulation, whether I am getting the same value 19.2 watt or not. Say this is RTH value, load resistance is same with RTH, this is open circuit voltage, and in main circuit I have used load resistance same as 1.76 ohm. Now checking whether power at main circuit and equivalent circuit are same with value 19.2 watt. Running simulation. See, in main circuit it is showing power at load is 19.2 watt. In equivalent circuit also it is showing power is 19.2 watt. So my calculation is perfectly okay.